Hello Internet, in this video we are going to be working on our magic revealing shader thing. So the idea here is we have this flashlight, and what we want to do is create a texture that is only going to reveal when the light is shining on it. So I'm sure there's a number of ways to do this. The way I'm thinking is dot products. So we can take the dot product of the forward vector of the light, and then the difference between the pixel, the fragment actually, and the light, and compare those two, and then run that through cosine, which should give us the actual point or the expected dot product, and then we should be able to just fade in and out. So that's sort of where we're going to be going. I was going to get some things started, but I started early because I planned poorly. So we're just going to jump right into it. So what I have so far is that square is actually using this revealing shader. It's just literally the default surface shader that I just generated. So there's nothing fancy going on there. But yeah, it works. So this is standard surface shader stuff. We've done this before. So what we need to do is we need to get the position of our light, the range of our light, so we can actually fade it in and out. I don't know if we're going to deal with that in this video. That's just another tweak, and there's a lot of tweaks that we're not going to cover here. Specifically, we're just going to be focusing on the fading in and out. So range-based, it isn't going to handle that for now. But what we do need is we do need a light position, or a camera position actually. We're not really going, so there's two ways to do this. You could actually pull this out. I believe Unity already provides this. I'm going to pass it in, and the reason I'm going to do that is because if I want to use this in like VR or something, the camera position and the light position are different. So we're going to use the light position and actually have a script that will pass that in. So we're going to do just a light position. So we've got our light position, we'll plug it in as a vector, and that just needs to be something like, oops, that's not going to work. We'll just initialize it to all zeros. Then we're going to want it down here. I'm going to use a float for this. So light position there, and that gets the position of our light. The other thing we want is we're going to want the world position. I think it's just world pose. And this will give us the world position of our fragment. So with those two, we can actually get the difference between the two. So I'm going to just plug this in and do world pose. Actually, let's do a calculation here. So the difference between the two, or the direction actually. We'll do direction is going to be equal to the normalize of our, we want light position, direction towards the light position, so it's going to be light position minus the world position, and that'll get us a vector pointing at wherever that thing is, so it'll get us the direction towards that fragment. So once we have that, all we need is the actual forward vector of our light, and we'll want that in world space as well, because both of these positions are going to be in world space. So we can just plug that in as well. So this, because of the way we're doing this, we could actually, like I said, we could pull these out from some of the Unity provided values, but since we're plugging them in, we're going to need a script to actually handle these. So we've got our light position. I want a light direction. Sure. And this is going to be a vector as well. Both of these are, there's only 4-dimensional vectors in Unity shader language, but we don't care about this fourth component. We can just ignore that. And I'm just going to default this to be down the z-axis. Then all we need is to actually bring it into our shader. So we've got our light direction there. And then we should just compare the two. So We're not going to do that yet. Instead, I'm going to pull out that rendering, and I'm just going to pass in our direction as the color. And this should render things once it actually compiles correctly. So I can pull that out. Don't need that. And then world pose. Input.world pose. There we go. That should clear everything up. And so this, let's see here. Let's grab our material, pull this up. So this is actually going to map the differences. Since this is the world position is in the center of this, we're going to get sort of this multicolored thing, and then black is going to be the opposite side. And there should be like a lighterish color there. So this is effectively what we're getting. But as we can, or as I'll show, we can move this around, and it changes how things look. Now that everything is kind of here, we have all of the values we need. What I'm going to work on next is actually taking this light direction and doing some fun stuff with this. So we have our direction here, and we have a light direction. So what we can do is calculate a scale. So this is going to be the... How do we want to do this? Scale will work, sure. So this is going to be the dot product of our direction and our light direction. So we're taking the dot product between the direction our light is facing and the direction towards wherever fragment we're at. And with those two, we should be able to actually figure out where things are in relation to our light. So the final thing we're going to need is going to be our light radius, degrees. What is it called on the actual light? The angle. So we're going to do a light angle, and this is going to be the angle of our light, so this way we can actually adjust that equal to our light. And it just needs to be a float. Or should we do a range? Let's do a range, sure. Between 0 and 180. And we'll just default this to like 45-ish. And so this is measured in degrees. And then we're going to need to convert our range into some sort of vector. So to do that, we need to... So the problem is dot product is going to be between 1 and -1. 1 is going to be perfectly in line, it's directly in front of you. And -1 is it's directly behind you, and then 0 is perpendicular, and then there's ranges in between. So if you look at that, that function actually corresponds almost perfectly with a cosine. It is a cosine. So we need to convert our light angle into a cosine, which we can do. So how do I want to do this though? We're going to call this the strength, I think. It's not a great name, but it's the best I can think of. So we're going to have the light angle here, and we're going to subtract. Actually, do we want to subtract? No. We want to subtract this from our scale. So our scale is going to be some vector. It's going to be how in alignment we are. And then we're going to subtract this off. So if our light angle is 0, only things directly in front of it are going to be illuminated, because this is going to be 1 directly in front, and this is also going to evaluate to 1, so it's actually just 0, and everything else is out. And then as we increase this, that cosine value is going to drop, and so more and more stuff is going to become illuminated. So that should get us the actual strength of our rendering. And then I'm going to bring back our color and do c.rgb. So we're going to take the RGB value from our texture and actually multiply it by that strength. So it should get brighter as we get in alignment and then darker as we move away. Or it won't compile and everything will go wrong. That's another option. Light angle. I was going to fix that. We didn't import it here, so we're going to do our light angle. And it still broke. I skipped something. And I don't know what. What's the error? That's totally different. Syntax error, unexpected equals, expecting parenthesis. Oh, we didn't close this. Got it. Done, fixed, solved. Cool. And so where we normally were getting sort of something that was lit, we should now be able to increase this. Don't tell me that's in radians. It's totally in radians. Okay, I was wrong. We need to convert this to degrees. Well, so it's in degrees, we need to convert this to radians. So there's 2 pi, or 2, for radians it's 2 pi is 360. So we need to multiply this by 6.28, 2 pi, divided by 360. And that's super gross. We can come back and fix this. Or we could just plug in an actual radian value. But this should solve it. Yeah, it does. Cool. So as we increase our light angle, you'll see it gets more and more powerful. It gets brighter and brighter. And that's because more and more of that shape is falling within this thing. And so we're revealing more and more. And so part of the reason it looks the way it does is because we are just doing a linear scale here. There's nothing fancy going on. It's not illuminated or not. It's sort of a scale of illumination. And that kind of works, but it could be better. So we can tweak that later, but for now it's doing sort of what I want. So instead of what we're doing now, I think we're going to actually keep our albedo the same, and instead tie this to our alpha. So our strength is now equal to the alpha transparency. And this isn't a transparent shader, so it's not gonna work yet, but we can make it one. So render type transparent. That's not everything we need to do. There's also an alpha flag here. So we have to say our shader is a transparent shader. And there's 2 other things that need to be added there that I can't remember. But that should get us somewhat started. Sort of. Oh, that's what I'm doing wrong. We still need that alpha transparency there. So we need to pull the alpha from our image, otherwise we're just getting a flat image all the time. And this way, it still doesn't look perfect because of just the way I'm doing it, but we can kind of see it's starting to work. Okay, so now that we have everything more or less working, we're gonna mostly work on touching this up. So we have this light angle. It somewhat works. What I'm thinking would be better is if we tune this strength a bit. So I'm just going to give an example of what I'm thinking of. We're going to do the min value between our strength, actually between the maximum, sorry, of our strength times, say, 16, 10, sure, and 0, so this will prevent it from going negative. And then for the minimum, we do between that result and 1, and that will clamp it between 0 and 1. And then we're just going to increase the scale here. So what that should accomplish is a higher fall off. So we're not pointing directly at this, which is part of the problem. But I should be able to get it working. So we're gonna actually leave that for now. Sorry, I'm all over the place right now. What we want is to create a script that can tie into this and actually pass the two values we need, the three values we need actually. So magic light source. And so this script is going to take the material. Oops. It's going to take our material of reveal, I guess. And then it's also going to accept a light. And then it's going to update this by whatever it is we send to it. So there's a set vector. And so we need to set the world position for the light, which is going to be light position. And then we just need to provide it a vector for. And that can be the light transform.position. And Unity will automatically make that a vector 4 for us. And then a light direction. Let me just make sure I'm getting these correctly. Light position, direction, and angle. And so this direction can be the transform forward vector. So this is going to be, in world space, it's going to be the forward angle of our light. And then the final one we need is going to be a float. And this is going to be something, light angle. That's going to be equal to our light's actual angle. Dot spot angle. There we go. So this is only going to work for spotlights. If you have a point light, it's not gonna work great. You can make it work. You could just set this to like 360 or something, and that would work, but it'd be weird. So come on. Cool. So I'm going to attach this onto our light, like so, and assign the material as well. And then the only other thing I'm going to do is execute an edit node. And this will make Unity actually execute our script in the editor. So we should be able to see in real time some of the updates that we're getting. And I think something's, why can't I change? Oh, because it's being set. Duh. What am I thinking? That isn't what I expected though. I was expecting this to work, which makes me think this may be backwards. So, yep. Okay. So that's our problem. We are looking at things in the reverse. So by doing the inverse of the forward vector, we're actually getting our proper thing to show. So it's actually showing up here. That's not really what I want. One more thing that I want to do quick. Add some emission to this, just to kind of keep things interesting. So we're going to multiply it by our alpha value and the strength. So this will just give it some emission. It'll make this emissive, which you may not notice here, but if we increase that emission by some absurd amount, it should make it bloom a bit, which we can kind of use to emphasize things. It's not really doing that, is it? No, it's not. Huh, that's kind of weird, but okay. Ah. Interesting that we can adjust the smoothness and it kind of shows up. And metallic totally breaks everything, that's good. I like when that happens. But yeah, we now have sort of a magic revealy majiggy, and I should be able to rotate this, and you'll notice the thing disappears as it falls out of our camera, or as it falls out of our light. So it's not there, and then it is, and then it's not, and then it is, and then it's not, and then it is. So it's all kind of working. It's just a little bit buggy-ish. So this is sort of the effect we're getting. The only thing that is a little bit concerning to me is it's still mostly transparent. And I don't know what's causing that, because I would expect this to largely solve that. Because we take our total scale, subtract off the cosine, and that should get us to ramp down, and then we clamp it within wherever. I don't think that's having any effect, actually. It doesn't appear to do anything. Maybe just because it's okay. Well, I'm getting distracted here, but it's okay. So if it's just there, it's less strong. So that's all that's doing, is making it stand out. Kind of expected that was sort of the intent, but I don't understand exactly why it's semi-transparent still. Because at that point, by multiplying it by 1,000, it should be significant. What if I increase the spot angle? That doesn't seem to have any effect. It does respond to that, though, which is good. So we can reveal more or less. But it doesn't seem to not be semi-transparent, which is weird. I don't know what's causing that. If I just do the alpha, that's also semi-transparent. So something else is going on here that is causing us to lose something. So one sec, I'm going to actually go and make this correct. This transparent and alpha, that's not everything we need. There's 2 more flags. I'm going to go grab those and see if that helps fix things, because I've had issues with those in the past. Okay, so what we need is we need a Q. So it's rendered as part of the transparent Q and not as part of the normal. There we go. That is much better. Not much better, but it's more what I was expecting. So that is at least somewhat correct. Now I need to pop off this 1,000 because I think that might be screwing things up. It wasn't? Why? Oh, I imagine. No, that doesn't make sense because our strength would cover that. I'm still confused. That seemed to solve it, but then it didn't. Because, huh. Yeah, I'm not actually, I don't know the answer to this. I was expecting it to not do what it's doing, to continue being like transparent right around here. And the fact that it's revealing the entire thing is confusing, especially when it's being partially transparent otherwise. That doesn't make sense to me. And if I change, oh, is it acting like a cutoff shader? That's a little bit funky. That's actually, yeah, that's really weird. And I don't, Sorry, I don't actually know what's causing this anymore. Because so there's our partial transparency. It seems to be off by a bit now, which is odd. But we can solve that. I'm very confused though why it's not lining up all the way. Maybe it's because we're doing some weird multiplication stuff? But no, it's because it's still there. So something's going wrong with this strength value. So we've got our scale, and we're subtracting off whatever the angle we would expect it to be is. So that should be cutting it off. Given a light angle, we're going to transform that into radians, and then subtract off whatever the value is. And so I would expect, so if it's 1 and our angle is like 0.75, we should get 0.25 as the result for something perfectly in alignment, which should be drawn, and then everything else should be cut off. And then if it falls on the other side, it'd end up being negative. And so this should be at 0. When this evaluates to 0, we should be right on the line. Unless my math is wrong, which is a possibility. This is definitely wrong now, but I'm gonna experiment with this because maybe it isn't. I don't know. So if we multiply by 1,000, why? Why is this even remotely right? By 100. So at this point, I'm more or less just plugging in values to kind of see what we get. And that actually looks better, which is a little bit concerning, but it works. So looks like 50 is probably going to be our good range, I guess. So if you plug in, I guess the strength that kind of makes sense will be sort of the strength of revealing. So if you have something that's super wide, it'll actually solve that problem all on its own. So if I go back to 10 here, it was very dim, but as we increase this, it falls more and more inside of it and gets stronger and stronger. So let's just add that strength scalar as an argument, and you can play with that to get the effect as you want it to be, because I think it's going to be dependent on what you're looking for. So we're going to just do strength is going to be a float, and we're going to set the default equal to like 50. Sure. Then we just need to plug it in down here. Everything was going so smoothly until that was weird. So we get all of that. It should all be good. I can go back into our game. Let's actually start this, and we'll see it actually what it would look like in game. So I have some like bloom and stuff applied, and that should kind of help the effect a little bit. But we can kind of look around for things, and it does the reveal effect, which is what we were going for. So it's showing services. Yeah. So for the most part, it works. It does what we expected. Took a weird detour to get here, but it works. There's one more thing I want to try. So I'm gonna go work on this a little bit on my own, and then I'll show you one thing that I had sort of in mind for an idea. and then I think we'll wrap things up. So be right back. I need to go pull something together quickly. Okay, so this is sort of one of the ideas I had. So in games, there's normally like some sort of quest tracker thing. So what I'm thinking is we can actually reveal quest tracker. So I just have a line renderer here that has this same shader. I did have to change two things. Nothing super important, but that alpha flag we had, I had to set fade. If I take that off, I'll show you what happens. We get this gross looking like block thing, and that just wasn't doing it for me. So by adding fade, it actually properly fades out, and we get this. And then the rest of the shader is totally the same, and that fade we probably want on the other one as well, because otherwise we'd get the same effect. So yeah, this is what this does, is it actually uses the light to reveal a path that's done by a line renderer like this. So I just have it go down the pier. So we can take our camera here, and if I go into like game mode, we can see it a little bit better. But I can actually rotate this, and it will reveal our path. This is a little bit funky because I'm using the same material, so I had to edit it. So this is just the material that we're using. I just didn't remove that decal. So everything else seems to work, and it just shows you sort of a quest path illuminated by your flashlight. So you can kind of rotate to reveal it, and then keep going, and it does it all dynamically. So I think that's pretty cool. I think there's a bunch of ways to use this effect, and I think this is one of the interesting ways. So yeah, if there's anything you guys are going to use this for, I'd love to see it. So drop a link in the comments, or let me know some way on Twitter or whatever. Yeah, I'd like to see it. If there's anything else you guys want to see, or any suggestions you have to improve this, let me know. This one got a little bit rocky in the middle there. But other than that, yeah, that's about it. So until next time, see you, Internet.